For centuries, we've basically had two different ways of trying to make sense of the world. One sees everything as a kind of giant, predictable clock, just ticking away perfectly. The other sees it as this tangled, unpredictable web of connections, a rhizome. So, which one is it? Let's dive in. And really, that's the big question, isn't it? For a very long time, one answer completely dominated our thinking, and it gave us incredible power. But then, well, that answer started to show its cracks, forcing us to find a completely new way of looking at reality itself. Okay, so let's start with the classic view, this idea that the universe is basically a machine. It works with this beautiful, predictable precision, just like a clock. Now, this isn't just some cute metaphor. This idea was the engine that powered the entire scientific revolution. So, what's the big idea behind this clockwork universe? Well, it's a philosophy called reductionism. And the logic is actually super simple and really powerful. If you want to understand how something works, you just take it apart. You figure out what each little piece does on its own, and then you mentally reassemble it. And this is not some newfangled idea. We're talking about the philosopher René Descartes, who really cemented this vision of the world as a giant clockwork mechanism. And in doing so, he gave us this powerful method that would just dominate science for more than 300 years.
The method itself just makes so much sense, right? You find the problem, you put a box around it. You break it down into its tiniest components. You figure out what each one does, and boom, you understand the whole thing. It is the absolute essence of analysis. And for a huge range of problems, it works.
And we really can't overstate how successful this approach has been. I mean, the clockwork paradigm is responsible for so much of our modern world. It's how we build engines, how we develop life-saving drugs, and how we calculate the exact trajectory to land a rover on another planet. It's a truly, truly powerful way of thinking. But what happens when the system you're looking at isn't like a clock at all? What happens when taking it apart actually destroys the very thing you were trying to understand in the first place? Well, this is where that beautiful clockwork model starts to shatter. And this wasn't some sudden event. The cracks started showing up way back in 1889, when Poincaré realized that something as simple as three celestial bodies orbiting each other was fundamentally unpredictable. Then came chaos theory in the 60s, showing how a butterfly flapping its wings could, theoretically cause a hurricane. And in the 70s, systems theory started talking about feedback loops, where simple cause and effect just goes right out the window. This all leads to this really fascinating paradox. In these systems, the whole thing has properties that are more than what the individual parts have. Think about consciousness emerging from neurons. The neurons themselves aren't conscious, but at the same time, being part of that system restricts the parts, making them less than what they could be if they were on their own. So that forces us to ask a totally different kind of question. If the real secret isn't in the individual pieces, but in the pattern of how they're all connected, well, then we need a whole new way of seeing. We have to shift our focus from the components to the relationships between them. And that brings us to our second metaphor, the rhizome. I want you to picture a sprawling root system, like ginger or bamboo. It has no single center, no clear top or bottom, no hierarchy. It just spreads. This is the world of complexity, where things are defined not by what they are, but by how they're woven together. The word complexity itself gives it away. It comes from the Latin word complexus, which literally means woven together. So this isn't about things being complicated or just difficult to understand. It's about them being fundamentally interconnected. You can't understand the fabric by just studying one thread at a time. The philosopher Edgar Morin gives us this great way to visualize it. A system isn't just a pile of parts. It's this dynamic interplay, this constant dance between three things: the system as a whole, the specific interactions happening between all its little elements, and the overall organization that just sort of emerges from all that activity. Each part of that triangle defines the other two. So what makes something a complex system? Well, they tend to self-organize without any central boss calling the shots. Think of a flock of birds or a school of fish turning in perfect unison. It's just simple, local interactions between neighbors that create these huge, unpredictable global patterns. And these systems are always open, constantly interacting with and being changed by their environment. Okay, so now we've got these two really powerful ways of seeing the world, the clock on one hand and the rhizome on the other. And this isn't about deciding which one's right and which one's wrong. Think of them as different tools in a toolkit, each one suited for a different kind of problem. And honestly, this might be the most important takeaway. The most crucial skill for any thinker or leader or creator today is being able to look at a situation and diagnose it. Are you dealing with a complicated problem that you can eventually solve, or a complex one that you have to manage and adapt to?
Let's make this super concrete. A jet engine is incredibly complicated. It has thousands of parts, but an expert can take it apart, understand every single piece, and put it back together. It's predictable. A traffic jam, though, that's complex. It emerges from the simple interactions of a bunch of different drivers all making their own decisions. You can't understand the traffic jam by just studying one car. The behavior of the whole system is unpredictable, and it can't be broken down.
And this table really breaks it all down. But if you're going to remember one thing, remember the goal. Clockwork thinking is all about prediction and control. But rhizome thinking, complexity, it basically gives up on perfect control. Instead, its goal is understanding and adaptation. It accepts that perfect prediction is often impossible, so it focuses on building resilience and learning to dance with uncertainty. So once you start to really acknowledge complexity, you realize it's not just a shift in science. It has these really profound implications for how we think about knowledge, about responsibility, and even about our own place in the world. And Wormer and Cilliers really nail it here. They say that if you can't possibly capture the entire system objectively, because it's just too vast and interconnected, then any model you build, any description you create, requires you to make choices about what to include and what to ignore. And those choices, they point out, can't be purely objective. They're guided by our values. And just like that, science has this unavoidable ethical component. This just completely dissolves that old scientific ideal of the detached, objective observer in a white lab coat. When you're studying an economy or an ecosystem or a society, you are part of that system. Your presence, your questions, your observations, they all influence the system, and the system, in turn, influences you. There's no outside anymore.
But let's be really clear about something. This is not a failure of science. Not at all. You could say it's an evolution. It's science growing up, becoming more mature and more honest about what we can know and what we can't know for sure. It's about replacing the illusion of perfect control with a much clearer understanding of our responsibilities inside these amazing interconnected systems.
Which leaves us with this final massive question. If the world isn't a clock that we can take apart and master, but instead it's this sprawling, unpredictable web that we are woven into, what does that demand from us? How do we figure out how to act when we know our choices matter, but we can never fully predict their consequences? And that's not just a question for scientists. That's a question for every single one of us.